Okay, whenever you're working on a synthesis, the first thing you always want to ask yourself is there a change in the carbon skeleton? And then second thing I ask myself, I don't know if I always phrase it this way, but I would look for changes in functional groups, but I always start with the carbon skeleton. So the reactions that we went over in this chapter that change a carbon skeleton would be the Grignard, and that's not new. Then we looked at cyanohydrin formation, so cyanohydrin formation, and then of course we covered the Wittig reaction. Now the Wittig and the cyanohydrin, those are the ones that are new, but we looked at all three of these in detail in this chapter. I just want to remind you that the second step in the Grignard can be water or H3O+. And so you should be able to supply the reagents for every single one of these steps that's shown in here. I'm not going to label them all, but you should be able to do them. And we learned how to take an alcohol and oxidize it to an aldehyde or ketone. We also know how to make aldehydes and ketones from triple bonds via hydroboration oxidation or by hydration. And once you have an aldehyde or ketone, right, then we get into all the chapter 19 reactions that we covered in here. So a lot of new chemistry in this chapter. And so let's say you wanted to do this synthesis here, okay? I'd start by counting. I have a total of 7 carbons. I have 8 carbons overall. And in terms of a retrosynthesis, if I want to put this methyl and this hydroxyl in the same position or on the same carbon, you know, my retrosynthesis to me would look something like this, where if I could make this compound, that would be 2-methylcyclohexanone, then I could just do a Grignard reaction and treat it with aqueous acid and I'm done, okay? So the question now becomes, well, how do I get to this ketone? Well, I could make the ketone from the alcohol. I could make it from this alcohol. And where would that alcohol come from? Well, I could make that alcohol from the alkene, right? And I know that since I'm just starting out with an alkane, the first step has to be bromination. And then I could just treat it with an unhindered base, and that would give me my alkene. Then I'd do hydroboration oxidation to give me the alcohol. Then I could oxidize with PCC or SWERN or chromic acid even, and then I just do my Grignard chemistry. And so that's the whole retrosynthesis laid out. So let's start our synthesis. The first step is going to be bromination. So for that, we're going to use bromine and light. Then we'll make the alkene using an unhindered base like sodium methoxide. That would give us the alkene that we want. Then we could do the anti-Markovnikov addition of water followed by oxidation. So step 1 would be borane and THF followed by hydrogen peroxide and sodium hydroxide. Then we could oxidize it. Let's use PCC. Students seem to like PCC, so we'll put that in. That's going to give us our ketone like this. And then the last 2 steps are just going to be methyl magnesium bromide followed by aqueous acid. And that is going to give us our tertiary alcohol that we're looking for. So this would be 1,2-dimethylcyclohexanol. All right, in D, we're starting out with 7 carbons and we're ending up with 9 carbons. And we're opening up the ring somehow here, so we know that we're going to have to make a double bond here and then do an ozonolysis reaction on that. But if we took that alkene, so if we took methyl cyclohexene, right, and if you treated this with ozone followed by DMS, what would that give you? 1, 2, 3, 4, 5, 6, 7. So you'd have 1, 2, 3, 4, 5, 6, 7. So you'd end up with this compound, okay? But then that still only has 7 carbons, but you can see that you could do a Grignard reaction here and here, and that would add these 2 methyl groups. And then we could just oxidize in the end. We can't oxidize this alcohol, but we could oxidize the alcohol we would get here back to a ketone with PCC or a SWERN or what have you. So there's our retrosynthesis. And so let's get started on the synthesis. So I'll just delete all this stuff. And we'll start out by doing our same thing we did in the last one. We'll do our bromination. See if we can get rid of that. We'll do our bromination with light. Then we'll treat it with our unhindered base. That's going to give us our alkene. Then we're going to do an ozonolysis reaction. Ozone followed by DMS. So then we have 1, 2, 3, 4, 5, 6, 7. So it gives us this ketone and aldehyde. Then, now we need to do a Grignard reaction here and here. So I'm just going to write excess. Oops, where's my black pen? I'm just going to write excess methyl magnesium bromide followed by H3O plus. And then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So then I'm going to have my hydroxyl group here, and I'll have a hydroxyl group here. But then to oxidize this alcohol, which is secondary, back to the ketone, all I have to do is treat it with some PCC or chromic acid, what have you. Let's use chromic acid for a change. So sodium dichromate, sulfuric acid, and water, and there's your synthesis. And for E, we're making an imine. And so if you do a retrosynthesis on the imine, it has to come from this aldehyde. So that would be cyclohexane carbaldehyde. And this would be called isopropylamine. So you need both of these. So we're just going to assume we have the isopropylamine. So now the question becomes, well, how do we get from here to here? We're just going to do an anti-Markovnikov addition of water, and then we will do a oxidation to give us the aldehyde. So we'll use a mild oxidizing agent. And so let's lay out the synthesis. We get enough room to just put it here. So here, we'll start with our, this is called methylene cyclohexane. And then we'll treat this with borane and THF, hydrogen peroxide, and sodium hydroxide. That will do the anti-Markovnikov addition of water. And I'm just going to do the oxidation in the third step, so PCC. We'll even throw in a solvent, dichloromethane. That would give us this alcohol. And so now to, sorry, I'm way off. That would give us the aldehyde, my mistake. And so now to give us the final product, we're just going to take it and we're going to treat it with our isopropylamine. We need a catalytic amount of acid like this, and we're just going to write here minus H2O, and that is going to give us our enamine, or sorry, our imine. Jeepers, Mr. Dion, I think I need another cup of coffee here or something. All right, there we go.